Welcome to the Web Developers Meetup for May. It is the month of May. I plan to present to you about JavaScript, and for some of you, you may be a little bit disappointed because I'm not going, this is not my DevCon talk, so there are some things you may be looking for that are not here. So the title here, mainly my goal is to get people to approach JavaScript differently than they do today. A lot of people seem to be afraid or scared of it and think it's some kind of monster that's going to get them in the browser. So to tell you a bit about myself, my name is Gary Pauly. You can read on the slide about me. The most important bit there is probably that I enjoy helping other people, followed very closely by the Costco enthusiast. If you haven't been to Costco or you don't go there for lunch regularly, you should. Less than $4, you're full for the rest of the day. Can't say that about some other places. So, more importantly, related to what I came to present on today. So, the agenda for what I want to cover are listed here. The first two are actually the agenda items. The other two beneath kind of describe them. So, I'm going to try and present the mindset I think you should have when you approach JavaScript code, but really it's coding in general. And then also the language features that you have in JavaScript that you should be taking advantage of, that you may not be, or that for some reason you're scared of taking advantage of. These features exist in almost every other language you've been using, maybe not in the same way, but the paradigms are there, you can use them. So along the way, I plan to mention some of the assumptions that you're making on the server when you run in Java or Ruby or any other language that for some reason you don't think are fair to make in JavaScript land, when in fact they are. And then in the end, I kind of hope by covering this information, you'll discover that JavaScript is actually a good language. Despite anything you may have heard me say in the past, it is still a good language. So, initially for JavaScript, the thing I want to kind of get out there is people's mindset when it comes to JavaScript. For some reason, this statement is what I hear a lot of developers say when they think about their code written in JavaScript. For some reason, everybody thinks, oh, my JavaScript's going to explode, it's going to burn down, my page isn't going to render correctly, I should be afraid of it. JavaScript will fail. Well, I don't really enjoy that mindset because oftentimes it leads to code like this, where you assume everything will fail, so you try to handle every possible failure scenario, and you end up with try, catches, or you end up with this wrap all the code on the page business, and then you just catch it. And I'll show you a slide later why that's also not a great idea. So really, the mindset that's here, if you were to broaden this, is that you're saying code will fail, which isn't inherently a bad idea, but I believe there's a subtle distinction that I'm going to point out between code will fail. I don't think that's how you should approach it. So on the server, we have a different mindset when it comes to failing. We have the errors we handle, and then the errors that are catastrophic that we do not handle. And you'll see something like this Apache 500 page that is, everything exploded, I don't know what to do. But for some reason, when it comes to JavaScript, we seem to think it's okay to gobble all the exceptions. Because the advantage of showing this page is the user knows something went wrong. They may not know what went wrong. They may have no idea what they're seeing. But if they know another human being, or they know how to contact the person in charge of the site, or a local administrator, they know, oh, this is an error, I should contact my tech support. Whereas when you gobble all the errors, you end up with something like this, which is an AJAX error, but because you gobbled up all your exceptions, that just spins forever. Your user doesn't know it's spinning forever. You haven't given them any feedback to let them know that it's not going to load. And this is what kind of bothers me with the code will fail mindset, because you're protecting against every possible failure, but when you do that, you leave inadvertent edge cases in your code where you end up leaving your users hanging, and they don't necessarily know what's going wrong. So I prefer to approach it from a code can fail standpoint. And the big difference here is that will fail You produce code that's verbose and not that legible, versus really all you need to do is can fail, wrap around the thing that you wrote that you know could fail, you know how it can fail, wrap that and handle it. Don't try to wrap everything and handle every possible case. And allow the browser to actually handle the errors, because most browsers are actually fairly decent at handling errors. As ugly as this looks, the user knows an error happens. There's no question. They know, oh, something went wrong. I can go and handle this. And that's because the code can fail, and you allowed it to fail, opposed to saying, oh, it will fail, I have to stop it from failing in all cases. Because you allowed it to fail, they can actually go and see the results of the failure. So that's kind of the initial push I want you to think about as we go through some of these features, is that you can allow your code to fail. You need to handle it gracefully, but you shouldn't assume it will fail. Because you don't assume all of your server-side code will fail. That's why you write tests, you cover it. You should do the same thing in JavaScript. So when it comes to language features, some of the things you normally get out of the box when you choose, say, Rails, Django, or any other framework you may use, is you get something that is consistent and stable runtime. Some of you may not agree about this. For JavaScript, manageable testing, which kind of does come out of the box for most languages. Most come with some kind of testing framework built in. Fortunately, JavaScript does not yet. You get error handling and built-in logging. The logging is the one a lot of you probably came for, and we will cover that last. That way you don't leave early. So when it comes to the browser, this is usually a support matrix that you might see for your applications. You support all the latest versions of browsers, and then some version of Internet Explorer and above. And this doesn't really seem awesome, right? Like, is it consistent and stable? I'm having to support what is the equivalent of basically running every Linux OS in each version of it. Well, it's not quite true, and even if that were true, all those Linux systems all have a base of Unix, which the analogy here for me would be that JavaScript at its base has its ECMAScript definition, which is consistent across most browsers whenever you use the core JavaScript functions and you're not doing something a little bit crazy, like mucking with prototype when you shouldn't be. So if you want to achieve something that's consistent and stable across multiple browsers, you should use abstractions like you do in any other language. We want a consistent and stable HTTP request and response, so we use a framework in any of our languages to handle web development. So which is a slew of libraries. We should do the same thing on the client. We should be taking advantage of libraries that exist that have been proven to work cross-platform, cross-browser without issues the majority of the time, followed by your code, and your code should be leveraging these libraries. This is how you produce the consistent and stable runtime. As soon as you start modifying those libraries themselves, you will encounter problems because you're taking it off of its implemented and purposeful course of action. And finally, there's the native core of the JavaScript runtime in every browser, which is not as performant across different browsers, but when you write normal JavaScript code, it will execute and do what you expect the majority of the time. So kind of an example of libraries that you can use on the front end. So everything on the left is an example of a library that helps you with DOM manipulation, CSS, and kind of making the UI look better. Each one of these works across multiple browsers and does what you expect. Now, on the right, you end up with visualizations. And so D3 is one that you can use if you use IE9 and above. If you're using D3 and you use something else, like a library called R2D3, and you expect your visualizations to behave the same whenever the rendered content is not the intent of the original library, you'll end up with broken visualizations and random errors, as you may have seen if you use visualizations using R2D3 and D3 expecting the same D3 code to work in both cases. So I don't know how many people have used that, but the core of the problem there is that D3 is an abstraction on SVG, and R2D3 in and of itself is an abstraction on VML, which is two completely different technologies. So that's an example of using a library in an unintended way, because R2D3 is an abstraction to D3, but then it goes and shims in VML. So that's an example of you don't have a cross-platform stable way if you're going and modifying the libraries, which is basically what you're doing whenever you dependently render something with the same code. So the next one on there is Flot, which is what I recommend if you support any version of IE 6 or 7 and above, because it renders out to canvas, which the example here on why that works in older versions of IE is because you can use a shim that shims the behavior in the browser itself using EXCanvas. And then from there, Flot is your abstraction for rendering visualizations. So that's right there. That visualization will render the same in all of the browsers because it's actually communicating the same way with Canvas. NVD3 is another example of an abstraction on D3 that works very well in IE9 and above. And then HighCharts is one that kind of works in all the browsers, but you have to pay quite a bit of money, especially if you are a massive organization. So, kind of related to that stable runtime, you can kind of verify your stable runtime by having manageable testing. In JavaScript, testing is manageable. Now, this might come as a surprise, but it is actually manageable. So I see a lot of people, when they write JavaScript, seem to think that it's really hard to do, it's not there, it's really messy, you might regret doing it, you feel filthy while you're doing it, you get done, you don't actually feel like you accomplished much, you're not sure you actually tested anything, but it can be done. It won't necessarily be the easiest thing you've done, but in any language you've written, as long as you've written your code well, it is testable. JavaScript is no different. The difference is that the paradigms in JavaScript are generally not what you're used to programming in, especially for web developers, because most web developers have used some kind of dynamic language that is more procedural and synchronous in its execution cycle. So this is how you should feel when you're writing tests. Like, you're a little tired, but you're still happy, you're going through the motion, you'll eventually get there, and your tests will be successful. So this gets back to libraries. So when it comes to testing in JavaScript, there are libraries that will help you. Jasmine is an example of a behavioral-driven test suite. Now, this is very useful when you're testing behavior, not units. So if you're using Jasmine to do unit tests, in my opinion, you're using it incorrectly because it is meant to test behavior, which behavior is generally what the user is going to do. My recommendation, if you're wanting to do unit tests in JavaScript, which I think you should do, would be to move on to Mocha or QUnit. So Mocha is a more generic testing framework that allows you to sub in different backends. So you can have one that behaves like Jasmine. Jasmine's similar to RSpec in syntax if you've used any Ruby code. So Mocha is cool because you can have that behavioral integration style test, but then you can also have your unit tests that you may be used to writing in Java or some other language that is very class-based. So you can write very similar tests using Mocha. And then QUnit is brought to you by the developers of jQuery. So if your application is essentially just jQuery, your testing framework likely should be QUnit, the testing framework used to test jQuery. So I recommend using it if you're just doing jQuery, which a lot of people do, but then for some reason they choose Jasmine as their testing framework. I highly recommend using QUnit instead. A lot of people complain that testing in JavaScript is too hard. They'll say, oh, my function's in a closure, I can't reference it, or oh, a lot of things happened and they're all hidden away and someone else wrote this code and I can't get to it. Well, that's too bad, because in any other place that you write code, if you're writing code for an orders system, you're going to verify that all of the orders placed are correct. You're not going to say, oh, that was too hard to test. So when it comes to the client side, you should still test them. In fact, usually the problem comes because people are unfamiliar with JavaScript and the way that the code actually executes in the runtime. So one way to kind of get around this, and I'll cover it later in error handling and show an example, is creating helper functions that you then individually test. And this all relates to try testing it indirectly. So one of the things I see a lot of people do is if they have jQuery, for instance, and they've attached a click event to a button that when clicked goes and updates some other widget in the UI. For some reason, people feel the need to go and create a fixture that is that widget over here, create another fixture that is the button, and then pull them both into the unit test, and then trigger a click on that button, and then verify that the widget that you created is updated properly. In my opinion, you're at that point, one, writing an integration test, and two, mostly just testing jQuery. This is where I believe trying some indirection helps. What you really likely want to test, if jQuery is what you're using, is that you pass the right selector and function to the bind of click for that button. And then all you need to do then is ensure it's bound on the right event. Individually test that when that function runs, it fires the event that your widget is listening to actually update. And then you can test each one of those functions independently. And by testing those small parts, you've tested the entire thing without having to go and create a bunch of mock fixtures that are completely unnecessary. And we can talk about that later if you think it's not. So next part of this is error handling. In JavaScript, as I showed earlier, a lot of people have different strategies when it comes to error handling. It can be kind of weird, and for some reason, when it comes to error handling, people seem to think these two are the most important concerns to have when you handle errors in JavaScript. Performance doesn't matter at all when you're handling errors, period. That's not what your concern should be. As some people find that surprising, performance in JavaScript matters, but error handling is not one of the places. So the reason is because an error, by definition, is an exception, which is exceptional, so it shouldn't happen often. If it's happening often, you have a different problem in your application. You shouldn't worry about the performance impact of catching errors or throwing errors in JavaScript. If you're using it for control flow, also a different problem. This isn't Python, so having exceptions raised to control the flow of your application is not a paradigm in this functional event-driven language. And you should not do it. The exceptions are exceptional and should not be what you're focusing on. So this gets back to the code can fail. You shouldn't be trying to build around will fail for all possible cases. You should just build around the can fail because your focus is creating functional value for your end users. So an actual issue in JavaScript when it comes to doing error handling, and this is one that can be tricky. So if I read through this code, you have a try-catch and a call that happens in the try, and then a catch that catches it. Well, what's different here is that try-catch is a synchronous operation, and it will go through. However, set timeout is an asynchronous event operation. It goes and puts whatever is passed with that function into the event queue. And Philip Roberts actually gives a really good 20-minute talk on how the event queue works in JavaScript, and I will have a link with my notes after this that you can go and watch that. But the big difference here on this try-catch is that set timeout goes on the event queue, and synchronous execution continues. So it's no longer actually, if that throws the exception, which it will because C, A, and B are not defined anywhere, that will throw an exception. However, you won't be catching it because it goes and happens on the event queue. It's been pulled out of the scope of that try-catch as soon as you put it in set timeout. So a way to get around this, which many of you are probably already thinking, so this relates earlier how I mentioned if you create helper functions, and this also is how the logger that I will mention here in a little bit works for the most part. Create your helper function. Well, your initial function that is what you want to do asynchronously every 100 seconds or just in 100 seconds after something loads. If you're doing some kind of asynchronous execution, this also, same thing, works for events. Here we have this handle errors function, which is handling the actual errors. It gets passed a function, applies whatever arguments happen, catches it, shows the error. So at the bottom, you can see the set timeout, handle the errors, pass the real function, and then time goes by. You will actually see that error get caught. And that's sort of one of the, I would say, gotchas that people have when they do asynchronous execution of JavaScript, is that they don't put the catching in the right spot. And this function here for handle errors, it is also in the notes that will be posted later. It can be modified to be used to kind of catch most errors, and you can generically do things with them. But why would you do that when there's some logging that can help you there? So to start off, logging in most languages is pretty awesome. You try except, this is Python because it's the best language. You try except, you log something. What's really awesome about most languages is when you catch an error and then you log an exception, you give your specific message, but usually that language will give you the specifics about where you're actually at in the stack, and you can see the entire trace all the way up. Now in JavaScript, that's not what happens all the time. This is one of the areas where consistent and stable is not necessarily true, but that's because this is the state of JavaScript logging today. It's very messy, and it's currently not really worth the work as it exists currently. Right now we have these nice functions that you see in a lot of languages that are around, you can log, same as you do in other ones, but the big problem here is that those happen in the browser. So if your 10,000 users are all throwing an error, you have no idea they're throwing an error unless they give you a phone call or you get a lot of feedback or angry emails from your users. So this is just an unfortunate state, and that's the difference. Key difference here is that on the server you have one execution, and across clients, everyone's executing your code. There's really no way for you to get it. Well, there is a way for you to get it. So I say solved. It's a big claim. So because the library is not officially released yet, its name is Canadarm. That function, which you would use, the way this library works is you watch it. It's one of the options, and then anytime you invoke that function later, if it throws an exception, that exception will then be actually logged in a distributed fashion. So the way that we have it currently set up is there is a proxy that gets the information and then aggregates it in one file the same way you would on the server. And that will be for use soon. So hopefully through this, something you've gotten is that JavaScript is and can be consistent and stable. If you use proper libraries and you don't try to build past your least common denominator, which unfortunately for most of us is some lower version of Internet Explorer, then you'll most likely be fine. And then also, everything in JavaScript can be tested the same way you can test it in any other language. There are no exceptions, really. You can test anything that you write in JavaScript the same way. You can test most anything in any other language you write. Error handling, also completely fine to do, and you can log. Logging isn't great, but it will get better very soon. That's actually what my DevCon talk is for. And you should come to that. So to get back to this, code can fail. Not will fail, code can fail. And when it comes to JavaScript, you should embrace that fact, that it can fail, that something might not go the way you want it to. And don't be afraid to use it. A lot of people seem to be afraid to use JavaScript to its fullest potential, and you should not be afraid to use it. It is usually a platform requirement for your application. So you shouldn't ignore the fact that you can use it. Now, this doesn't mean you should only use it and not do anything on the server. It just means you can rely on JavaScript to keep your front end stable. So rather than just ignore that it's there, allow JavaScript to empower you to create better applications. And the one thing that is currently lacking, that may be why you're not currently giving it as much use, is the logging. And that will be made much better soon. So, does anyone have any questions or feedback?
You mentioned you don't like fixtures a lot. Do you think there's any place where they are appropriate?
All right, he said that I mentioned I do not like fixtures very much, and are there times I think they are appropriate? I do think fixtures are appropriate during integration testing.
Okay.
However, most of the time I have seen them used in the applications that I have developed, they're being used for integration tests that should really be unit tests, which means the fixture usually is not needed. Now there are cases, in that example of what you wanted to test was the end-to-end interaction of the button click and this thing updates, that's still a valid test, and you may want those tests. That's when I would say you should use the fixture, but most of the time the person is actually just wanting to validate that the button click fires an event, and this thing, when an event is fired, actually goes and updates, which neither one of those require fixtures.
I do have a question on that as well, mainly your opinion. So what you said earlier was the best way to test an event is you want to make sure that you call in the correct event, the correct selector, and that basically you have to expect this function or the jQuery's on to be called in selector, event, function. And then I think you said earlier you want to test that when you fired the event that it got triggered, correct?
Correct.
Don't you think that'd be too much of an integration though? Like it feels at that point that's more of an integration. Because I felt like if you just tested the on method that was called, and then you test the function by itself, that you'd still get code coverage that way. It does feel like you may be moving towards an integration if you see that, oh, this event was fired on a specific element. So it still feels like you're using some fixtures there.
I'm not sure I understood the question.
So basically, would an event triggering really be that necessary for behavior tests like that?
I see. So earlier what I mentioned was, it was really 3 separate tests. You have your one test that validates that you're attaching some function to the click event on your button. You have another test that validates that that function does what you want it to do, and that you're probably having it fire some kind of event, or calling another function. Then, separately, you have your third test, which is likely a function, or that you have actually bound a listening event. So say that function that fires on that click event fires a custom update UI event. You want to validate that you're actually listening to that custom update UI event with that update function. So those would be 3 separate tests. And then you likely would have a 4th test that also tests the custom update UI. And that's assuming that you are firing an event after you click the button, which some people do. Some people would just wrap that in another call. Just depends on your choice of JavaScript. Yes?
I know you mentioned that when you, on the same example of clicking and seeing the difference, and you're not trying to test jQuery for sure, but don't you, as an owner of a module, want to know if there, let's say the future version of jQuery actually introduced a bug which affects you? Don't you want some unit test which should fail in that scenario so that I know, hey, I need to drop the version of jQuery to a lower version which actually works? Like I do a mix of both. I do that. I consider both as unit testing. Depends on person to person. I just want your thoughts on how.
Right, so the question there was when it comes to doing that unit level test I just described, you're not actually testing any jQuery there, so what happens when you update to, say, jQuery 2.0, which has the same API but just won't work in certain environments? So there is where I would actually, that's where the integration test, and that's my key difference between what is a unit test and an integration test. The integration test validates that full through your stack, so the native JavaScript, your code, and your library code is all working together correctly, whereas the unit test should be testing your code and the core JavaScript. So that slide I had earlier with the 3 levels, I would consider integration test as soon as you bump into that first point with libraries. To me, that is an integration test. As long as you're in the your code section when you're writing your test, to me that is a unit test. So I do think it is valid to have those integration tests for testing various versions. That's the only way you can know that a major upgrade is not going to destroy your application. But I do think both tests are important because oftentimes what may happen is that when you're doing your unit test, it will fail, but it's not failing because of jQuery, it's failing because of something you may have mocked incorrectly or you did something wrong, and then the jQuery call is failing because you passed in some object that isn't valid for an internal function of jQuery because you tried to mock things. And this is why I think both of those tests are important, because it allows you on the unit test to focus on your code, and on the integration test to focus that all the way through the stack everything works.
So, to kind of play devil's advocate, the point you said of where it will fail, all web pages start with JavaScript failing because all pages start without JavaScript. So basically what I'm saying is your page does not have JavaScript until it's downloaded.
True, but it has a JavaScript runtime the entire time. So your page can be there, and this comes into the performance of your application, where errors don't matter, but the performance does. So if you render your page and then it takes 20 seconds for all of your JavaScript code to update and actually make the UI useful, then that is a problem. But I don't think inherently using JavaScript is a problem, and your page does have JavaScript. If something for your page is completely necessary, must have JavaScript, then that can be in your head, provided it does not have a performance impact that is more than like a quarter of a millisecond or less. But for the most part, I would recommend you create your page in such a way that you write HTML, it would look acceptable, and your JavaScript enhances the page. Now, in that vein, it is very possible parts of your page just won't work without JavaScript. So for instance, say you have some kind of selector where you can choose any country in the world, followed by, as you fill it out, you can then choose all the provinces or states, and then the counties, and then the cities from there. You wouldn't load all of that on the page. You would require JavaScript to asynchronously load that. I think there are separate concerns there, and it's not just my page needs to run without JavaScript, because if your page needs to run without JavaScript, then you're saying you don't support JavaScript runtime for your applications, or you don't expect people to have them, which would be a sad day in web development.
Well, what if someone's corporate firewall blocks all JavaScript?
So if someone's corporate firewall blocks all JavaScript, I wouldn't necessarily care to support them, because that is an issue that is not on the website, like not the website's fault. It would also, to me, be akin to running a native application and then blocking all of the ports that that native application uses to communicate with itself internally. Like it's the same problem in a different way that manifests itself in any type of application. If you remove the application's ability to properly execute, then there's not much someone can do to make it run in those circumstances. You will always hit a point where your code can fail.
Right, but that's, I think that's the argument that was trying to be made, was to always support progressive enhancements so that when it does fail, your application is still useful in some way. Like I said, I'm just playing devil's advocate, throwing the other side at it, but I think that's the argument that they're trying to make.
Right, so the point that Rory made is that the application should still be usable without JavaScript. I would actually argue that that isn't necessarily the case going forward in web development unless your biggest concern is mostly underdeveloped nations on mobile platforms, which is very common now, because they usually have slow internet connections, so it can lead to packet loss and not necessarily getting all the JavaScript. But
you said a very important word, usable, right? Don't you need to degrade to the point where a screen reader can use it? JavaScript is so that.
right, so accessibility is still something you should do in your applications. That is independent of JavaScript, but there are some interactions that you cannot achieve, some UI things that people want that you cannot achieve without JavaScript given the state of HTML today. So for instance, if you want to have an ordered multi-select, you can achieve it in a very rudimentary way using just HTML. But if you give yourself JavaScript, you can have those nice multi-select widgets where you slide something over, you can move it up and down. But given just HTML, no JavaScript, your options are very limited to input boxes with cardinality selectors that you fill out yourself. So I would say that if you don't have JavaScript at all, you've already kind of lost your usability of your application, given a sufficiently complex application. All right, I guess that is it. Thanks everyone for coming. And you're welcome to stay, keep chatting. It's encouraged, actually. That's what these meetups are for. Also, important note, you should always give citations to images you take from the internet. It's a legal requirement.
That was